Hi guys, welcome to Intermediate Algebra. We're starting chapter 6 and the topic of the day is rational expressions. Recall that with a rational number can be expressed as a ratio of two integers. So for example, 3/4 or 5/6 or 279.684. Really? Yes, because 279.684 is the same thing as 279,684 divided by 1,000, which is a ratio of two integers. So it is a rational number. In the case of rational expressions are a ratio of two polynomials. So for example, say x over y, or 3x plus 1 over x minus 5. Or say 5x over x squared minus x minus 6. All of these are rational expressions. They're ratios of two polynomials. The question that we're going to be asked at the beginning of this chapter is, for example, in this situation, for what values of x is this expression undefined? So let's go back to our rational numbers where we have ratios of two integers. In the case of 3/4, you can visualize this as a circle, say, or a square, or any shape you want, divided into four equal parts. And if I shade in 3 of those, that represents 3/4 of the circle. In the case of 5/6, now I divide this into 6 equal parts, like so. And quickly, before anybody notices, shade in 5 of those. So it would be 1, 2, 3, 4, 5 of those 6 pieces. And that represents 5/6 of my circle. If I had a ratio that was, say, 3/0, however, what would that mean? Now we have a circle divided into no parts. That makes no sense. And in math, we refer to this as being undefined. Whenever the denominator is equal to 0, that number is undefined. Same thing is true for rational expressions. So if we go back to my example here of 3x plus 1 over x minus 5, for what value of x is this undefined? Well, we want to find out for what value of x is the denominator equal to 0. So let's set the denominator equal to 0. We would have x minus 5 equals 0. Adding 5 to both sides, x equals 5. So this rational expression is undefined for values of x, for the value x equals 5. Let's do an example here. Let's say another example. So say I give you the equation y equals 1 over x plus 3. If I were to actually plot that on the xy coordinate plane, you don't have to be copying this down, by the way, just watch and learn. It's alright if you jot a few notes here and there. But if I were to plot this up I'm just going to go 1, 3, 1, 2, 3. Okay, minus 1, minus 2, minus 3, 1, 2, 3. I plug in a bunch of values for x and find out what y is. What I'm going to find is that this graph makes a curve that looks like this. And that's part of it. The other part of it is going like this. What we find is that as x approaches this value of -3, the denominator becomes 0. If you approach -3 from this side, the value of y goes up towards positive infinity. But if you approach x equals -3 from this side, the value of y goes down toward negative infinity. So it's not good enough just to say that 1 over 0 equals infinity. It could either be positive infinity or negative infinity, but it's nothing in between. So that's why we call it undefined for x equals -3. It's undefined. If we do practice number 1 out of your textbook, the problem they give us, I'm now on page 443, so this is page 443, practice number 1. Not example 1, practice 1. They give us the ratio, the rational expression, 2m minus 7 divided by m plus 4 equals, well, not equals, they just give you that expression. Then they ask, for what value of m is this expression undefined? So once again, we're just going to take the denominator here and set it equal to 0. If we have m plus 4 equal to 0, then we know that m equals -4. So for the value m equals -4, this expression is undefined. I want to do a slightly more complicated example of this. In example 1, part B, on page 443, we are given the problem, the expression 5x over x squared minus x minus 6. And find the value, the question is find the values of x that make this expression undefined. So same thing again, even though the expression in the denominator is a little bit more complicated, we still want to set this denominator equal to 0 and then find the values of x that make that expression, that equation, true. So we'll have x squared minus x minus 6 equals 0. And we want to factor this, as always, same thing we were doing in chapter 5. And we can do that by breaking this up into two binomials. Let's see, what are my factors of -6 that add up to -1? How about -3 and a +2? That'll work. But that gives us two possible answers for x in order to make this equation equal to 0. X can either equal 3, which would make this part of this binomial equal to 0, or x can equal -2, which would make this binomial equal to 0, and then multiplied by that, the whole thing is equal to 0. So in this case, there are two possible answers, x equals 3 and x equals -2, that will cause this rational expression to be undefined.